Hello everybody, today we're going to talk about the mole and molar mass.
Imagine you have a coin. It weighs 5 grams. Imagine you have a pile of these coins. Altogether, they weigh 75 grams. How many coins do you have? One way to count all the coins is to simply count it. But eventually, this takes a long time. Is there a better way of counting the coins without physically counting each one? Well, what if you had a scale? So if you put all the coins on the scale and you measured how much the coins weigh,
Then you can divide the total mass of all the coins by the mass of just one coin.
well, 75 grams divided by 5 grams per coin equals 25 coins. Did you get it? Good. What would you do if it was your birthday and someone gave you a truckload of these coins? Probably the same thing. You would need to know how much the coins weighed in total, divided by 5 grams. That would tell you how many coins you have. Alright, so you determine the mass of the truckload of coins. It's 12,645 grams. So we divide. 12,645 grams divided by 5 grams per coin equals 2,529 coins. That's a lot of coins. Now usually, when dealing with this many coins, you want to bundle them up into bags. Let's assume that each bag has 602 coins. We'll come to why we picked that number later. So let's use the same truckload of coins. How many bags of coins are there if the amount of coins weigh 12,645 grams? Well, let's use the same strategy. You need to know how much a bag of coins weighs. Each bag of coins has a mass of 3,010 grams. So we divide the total mass of all the coins, 12,645 grams, by the mass per bag, 3,010 grams. That equals to 4.2 bags of coins. Can we have 0.2 bags of coins? Yes, we can. So this example shows you the process of figuring out how to count the numbers of atoms in any element that you can find on the periodic table. We all know that atoms are really small. Therefore, the mass of one atom is extremely small. Probably not useful to use when trying to calculate the numbers of atoms. What would be useful is to count the number of bags of atoms, but every element has a different sized atom. You remember this from drawing all the Bohr-Rutherford diagrams from previous years. So therefore, the mass of bags of atoms depends on the element that you're measuring. In the 1800s, Amedeo Avogadro created a method of calculating the number of atoms and elements. Instead of using what we used, bags, he created the term called the mole. 1 mole is equal to 6.02 times 10 to the power of 23. Kind of like a dozen is equal to 12. When you have 1 mole of an element, the mass is equal to the number that you see on the periodic table. So in grade 9, you learned that the numbers on the periodic table represented the mass of the atoms expressed in the units of atomic mass units. Now we are using those same numbers to
calculate the mass of 1 mole of any element.
So for example, if you have a 12.01 grams of carbon, you have exactly 1 mole of carbon atoms. In other words, you have 6.02 times 10 to the power of 23 atoms of carbon. That is 602 sectillion atoms. 1 mole of magnesium atoms has a mass of 24.31 grams. So
we get 24.31 from the periodic table.
1 mole of sodium atoms has a mass of 22.99 grams. Also, that's 6.02 times 10 to the power of 23 atoms. Some of you may have figured this out already, but if you have any mass of an element, you simply divide that mass by its molar mass found on the periodic table. So for example, if I have 100 grams of carbon, that's 100.0, you would take that 100.0 grams and divide it by the molar mass of carbon. What's the molar mass of carbon? 12.01 grams per mole. So 100 grams divided by 12.01 grams per mole equals 8.326 moles. So that means that you have now learned the equation for determining the number of moles of atoms in any sample. You simply take the number of moles equals mass divided by molar mass. So the equation is moles, symbolized by the letter N, is equal to mass divided by molar mass.
Let's take a look at molar masses. The molar mass is the mass of 1 mole of a particular substance. So carbon's molar mass can be found in the periodic table. It's 12.01. The units for molar mass is grams per mole. So the molar mass of carbon is 12.01 grams per mole. So you'll notice that there's 4 digits in this number. What is the molar mass of a molecule of oxygen? So since there's 2 atoms of oxygen in the molecule, O2, you would look up the molar mass of oxygen, 16.00 grams per mole, and you would multiply it by 2 because there's 2 atoms of oxygen in the molecule. So 2 times 16 is 32 grams per mole. If we were to figure out the molar mass of water, we would write the formula out for water first, H2O or HOH. So there are 2 atoms of hydrogen in the molecule and 1 atom of oxygen in the molecule. Looking at the periodic table, we find that the molar mass of hydrogen is 1.01 grams per mole. Multiply that by 2 and add that to 16 grams per mole. This gives a total of 18.02 grams per mole. That is the molar mass of water.